In this video, I'm going to go over how to name ionic compounds with metals with more than one charge and using polyatomic ions. These are the 7 metal ions that have more than one charge. You are to remember what they are. An easy way to remember them is by looking at the periodic table. Looking at the periodic table and 7 metals with more than one charge, you can note that chromium, iron, cobalt, copper, tin, mercury, and lead. These elements have more than one charge. It would be very helpful to know where the elements are on the periodic table and what their charges are, like which ones do 1 and 2, 2 and 3, and 2 and 4. There are certain elements that only have one charge. That is part of the transition metals. They include aluminum, zinc, silver, cadmium, nickel, and manganese. To know what these charges are, it is helpful to see the trends. If you look at aluminum, zinc, and silver, they're going down a staircase. And aluminum is a +3, zinc is a 2+, and silver is a 1+. If you look right underneath zinc right here, it's cadmium, which also has a 2+, which makes it easier for it to know. Workbook, you have this list of polyatomic ions that you need to memorize. You need to know these polyatomic ions to do a lot of your naming. You must learn to work with this particular table. You need to be able to use this particular table. So how do we do this? Let's take iron, for example. Iron has 2 charges. Let's just take a nonmetal to make it a metal plus a nonmetal, and oxide. Oxide is a 2-. So if a iron 2 comes together with an oxide, then this charge goes down there and this charge goes down there, and since they're both 2s, they could cancel out. So an iron 2 would be FeO, and you would name it as iron Roman numeral 2 oxide. Whereas for the iron 3, you take this down here, you take this and you put it down there, so you would be Fe2O3, and you know this would be iron Roman numeral 3 oxide. And so that's how you know the charges on the metal, which one to use. Let's do another example. Let's take copper. Copper has 1+, and there's a copper 2+. Let's just take phosphide. Phosphide is a 3-. So a copper 1 phosphide, you take this one, put it down here, you take this one, put it down there, so it would be Cu3P, and this would be copper Roman numeral 1 phosphide. Whereas copper 2 phosphide, you take this and you put it down there, take this, you put it down there, so you would be Cu3P2, so this would be copper 2 phosphide. Mercury's kind of special. There are 2 mercuries. Mercury 1, that's Hg2, 2+, and a mercury 2, Hg2+. This is a dimer. So what in actuality, there's 2 mercuries bonded together, each with a +1 charge. That's why it's an Hg2, because it's bonded together, each with a +1. Since there's 2 of them, that's why it's overall charge of a +2. So this is what mercury 1 looks like. So if this mercury interacts with, let's say, nitride and 3-, you would take this number, put it down here, and you take this number, put it down here. So in this case, you would have to write Hg2 parentheses 3N2 for mercury 1 nitride. The reason why you don't put Hg6N2 or Hg3N, you don't use any of these right here. This is not quite correct because this is a dimer. This mercury is a dimer. So this 3 right here means that there's 3 of these Hg2s. So what does that look like? So let's just draw it. When you have mercury 1 nitride, it would be, you have 3 of these, and each of these has a +1 charge. So that is a +6 charge overall. And you have nitrogens with a 3- charge and a 3- charge to balance out all the charges. So over here, this is a +6 and this is a -6, because this is a dimer and they kind of come together. So for the mercury 2 nitride, it would be Hg3N2. So let's just do some examples. Silver nitrate. Let's see if you could write the formula for silver nitrate. If you look at your table, you know that silver is Ag, positive 1 charge. Nitrite, it's NO2 minus. And so you put these elements together, so it would just be AgNO2. Let's try lithium carbonate. Looking at the periodic table, lithium is Li plus, carbonate is CO3 2 minus. So you're going to have to take this charge, put it down here, take this, put it down there, so you get Li2CO3. Let's try magnesium phosphate. Magnesium is Mg2 plus. Phosphate is PO4 3 minus. So as before, we take this and you put it down there, you take that and put it down there. So it would be Mg3. So now this 2, you need 2 phosphates altogether. So you need to put parentheses, PO4 and parentheses 2. You use these parentheses when you have dimers of polyatomic ions that you need to indicate the number of the whole thing. If you forget this parentheses, you'll be marked wrong. Let's try cobalt-3 hydrogen phosphate. Cobalt-3 is CO3 plus. Hydrogen phosphate is HPO4 2 minus. So what we're doing before is take this and put it down there, take this and put it down there. So you got CO2 parentheses HPO4 3. That is cobalt hydrogen phosphate. Can you name BaOH2? Well, Ba stands for barium, and we know that barium has a 2 plus charge, so that means that this 2 comes from there, and that means we have assumed there's a 1, so this is a negative 1 charge. If you look on the polyatomic ion page, OH stands for hydroxide, so it's barium hydroxide. Let's take a look at Al2C2O43. Al stands for aluminum. And we know that aluminum has a 3 plus charge, so that came from there, and this 2 came from this right here. And this, if you look on your polyatomic ions, it is oxalate, so it's aluminum oxalate. Let's take a look at Li2O2. It's interesting because we know that Li stands for lithium with a plus 1 charge, and O usually stands for oxide. But where did this 2 come from? From the bottom of lithium. Well, if you look on your polyatomic ion page, you also have an element called peroxide. So peroxide is also another dimer. It's O2 2 minus. So it's O with a negative 1 each. So this is a peroxide. Very highly reactive. So this would be lithium peroxide. Now we have NH42SiO3. NH4 is ammonium, has a plus 1 charge. So this 2 must come from this particular element because there's an assumption there's a 1 here. So this, according to your polyatomic ions, is silicate. So it's ammonium silicate. Let's look at PbO2. Pb stands for lead, and lead has 2 charges associated with it. It has a plus 2 or a plus 4. And this element right here is oxide, or it could be a peroxide. Well, that's funny because there's a 2 here, and there's assuming a 1 here. If it was peroxide, then there has to be a 2 and a 2. But if it's oxide, then it has to be O2 minus. If it was lead 2, both charges would cancel out, so it would be PbO. Let me write that for you. So if it's lead 2 oxide, it would be PbO because the lead has a plus 2 charge and the oxide would have a minus 2 charge. And so these charges cancel out, would be PbO without the floating charges right here. So that leads this to be lead 4 or something with a peroxide. I'm saying it is a lead 4 oxide. Why? So if this is lead 4 and this is oxide with a 2 minus, that means this 4 was taken down here, this 2 was taken down here. So it would be Pb2O4. But I put it as the lowest common denominator in this case, so this would have to be PbO PbO2 for lead 4 oxide. You're like, whoa, whoa, whoa. How come the others weren't lowest common denominator, but this is a lowest common denominator? Well, what you notice is that the others that we're talking about, the peroxide and the mercuries, are dimers. Lead and oxide are not dimers. So therefore, you have to put the lowest common denominator. So what would lead 4 peroxide? So lead would be Pb4, peroxide PO2 2 minus. So you would take this and put it down here, you take this and you put it down there. So you would get Pb2O24. So in this case, you could reduce it down a little bit more. So it's PbO22 or lead 4 peroxide. And that's how you name using metals with more than one charge and polyatomic ions.